Hey folks, welcome to our channel. Today we're going to talk about OpenTelemetry and Python, specifically how to get started with OpenTelemetry in Python. What are we going to do today? We're going to talk about a few points. What are traces? Why we need traces? How does it actually work? Where's the magic? We'll talk about a bit OpenTelemetry. What exactly is OpenTelemetry? You're probably hearing this name a lot. So we're going to talk exactly what is it, what it means. And then we're actually going to implement OpenTelemetry in a Python app. We're going to have a bit of a coding session. So follow along. I'm going to be using a Specto for our traces backend. They have an awesome free tier that you can use, no credit card required. So go on, set up your account, and be ready to send your traces to a Specto. So why do we need traces? Like, why are we hearing about all of this now? So actually, it's related to microservices. So there's a big problem when everybody's migrating to microservices. It's getting very hard to debug issues in microservices because in the past you used to have like one big application that was running all of your business logic, and you would just see an error and you could follow the stack trace and see what happened, why it happened, and you have all the information in one place. But now you suddenly have 500 services talking to each other and you have an error. You don't know exactly what is the source, what is the root cause of this error. Maybe it's happening only when a specific service is sending a message to my service. Maybe it's happening for a specific user. It's getting very, very hard to debug issues in microservices, and that is why we need traces. So let's look at an example when it's very hard to debug. We'll talk about an error in microservices and see why and how traces can help us. So in this example, we have service A. We're getting an error that we can't write to DB1. So we go into the logs, and in the logs, we see an exception. We see that we have some exception, can't write to DB1. Okay, so we're looking at our metrics. We have a Prometheus is collecting metrics, so we can look at the CPU. And we can see that there's a very high CPU in DB1. But how do we know what is causing this increase? What is causing this CPU increase? Maybe it's an increase in traffic, but what exactly? Can we know what route is specifically causing this CPU increase? Maybe there's a different type of communication. Maybe someone is reading a message from a message bus from Kafka, let's say, and putting it into the database, and now we have a high volume of messages, so we see an increase in CPU. So you see we have here a service that is showing an error that it can't write to a database, but we don't actually know what is the root cause of this error. So let's look at this diagram and see how it looks like. So you have service A talking to database 1, but then we have service B that is talking to service A. But we actually also have service C that is also talking to service A and then is writing to the database. So actually we have two different paths of execution here that all go to the same place, but we can't distinguish between them. So logs tell us there's an error. Metrics tell us there's a very high CPU, so it's a technical why. And a trace will actually give us the context, and it's like a stack trace or a path within the system, so we can see exactly that this request that is causing a high CPU came from service A to service A from service B, or specifically from service C. And this is how a trace would actually look like in a Specto. So you can see exactly a request. You can see where it started from, where it went in your system throughout a message bus, who received it, what database was called, and you can actually have a view of a timeline like you see here below. They can see over time where the request was and where it spent. You can see that this request took almost 3 seconds, and you can see that most of the time it was spent on update operation in a database. So this is very useful for debugging flows across different services. So that is a trace. So we heard the trace, we know what a trace is, but what is OpenTelemetry? So a bit of a history. Actually, there was a few different technologies used for tracing. In the past was one called Open Tracing and one was called the Open Census. And they both merged to create OpenTelemetry. OpenTelemetry now is a standard in the industry for collecting telemetry data. So what does it mean? First of all, it's a project under CNCF, the Cloud Native Group, the same group that is that Kubernetes is under. So we have OpenTelemetry under the same group, and it's actually a collection of tools, APIs, and SDKs to create standard OpenTelemetry telemetry data. So what it help us collect, generate metrics, logs, and traces. And they give us a set of SDKs, and specifically, we're talking about Python, so they gave us a set of SDKs for Python that you can download and implement in your application and start collecting traces. So how does it actually work? How do I generate that beautiful trace you saw before, this interaction between services? How does this magic happen? What does OpenTelemetry actually do? So let's say the same example we had before, service A, service B, database. So you would actually install an SDK on each service. You have service A, it has an SDK called OpenTelemetry, or in short, OTel, and you have service B also has this OTel SDK. And what actually the magic that we have in OpenTelemetry is the context. Basically, OpenTelemetry injects a context to all your interactions, and that way we can follow a request from the beginning throughout your system to a database. So OpenTelemetry will actually add to each request something called the context, OpenTelemetry context, which basically would say this operation is being done under the context of one trace. So let's say service A is getting a request. It would generate a trace ID, a span ID, and would send this to your tracing backend. And then service B when service B would get a request, it would know, because it has a context, would know I'm under a different trace ID. I'm under trace ID 1. Span ID would generate something, and it would send it to the tracing backend. And when you're making a DB query, it would also generate a span saying, this is my trace ID, this is span ID, and would also send it to the tracing backend. And since all of these atomic operations share the same trace ID, we can basically grab them all and look at them over time. So this is how the magic happens, how OpenTelemetry knows to create these beautiful graphs for you. And what can this actually help us do? It can help us when we have production issues. It can tell us why is something failing, where is the issue. If something is slow, you see one endpoint is slow, you can actually look at the trace that shows the entire flow and say, okay, it's actually slow because service B is doing some heavy operation, and that's where you need to optimize. And service A is just a side effect of that issue. And basically it helps us improve our immediate time to respond and help us solve issues in production much quicker. So let's do some, let's show you some code and see exactly how you can start with OpenTelemetry in your application. So here we have a pretty simple Python Flask application. We have a to-do API. And what we have in this API, we have a few routes. We have a get to-do that basically calls an external API and returns a list of to-dos. Before that, it goes to another service that we have here, a user service, which will return the current user that is logged in. We're actually not doing anything with that user. It's just for demonstrating this data, this the example of two services interacting with each other, and we're returning to the user the to-dos, and then we have another to-do route. We can have a specific ID, and then we're going to return this to-do with this ID to the user. Pretty simple. In the user app, we just have one route called user/profile. We're actually returning just the user ID, email, organization. We're not actually doing anything with it. So let's go and see how we can set this up. So this is after I logged into a Specto. Go on, you can sign up. You don't need any credit card. And let's get started. So let's say I'm new to OpenTelemetry and I'm using a Python application. So it's very simple. Or with Python, you need to install only a few packages. So in this case, OpenTelemetry instrumentation, the distribution, and the exporter that will help you send the data to a Specto. Let's go along and add this to your application. I already added them to my requirements. So we can see here I'm using Flask and requests. Flask is my web framework, and request is I'm using it to send a request externally. So I'm going to add the instrumentation for them as well. So I'm going to add them to my to-do service, and also you can see in my user service I'm adding them as well. And then I'm gonna go and want to set up my environment. Basically, I need to add to my service to tell them to what endpoint I'm going to send the data. So you have here the Specto's URL address and a header with your authorization token, basically to identify your account. So I'm going to go ahead and copy this, and so I added the token that you just got from a Specto to your configuration. This is an environment variable, so you need to set only a few environment variables. So you're going to set your service name. So in this case, it's the user service. I just set it to user service. Here, I'm going to set it to my to-do service. You're going to set the endpoint. This case, it's hotel call a Specto IO with a specific port. And you're going to add your authorization token. So I'm just going to, let's run this. Use Docker Compose up. We basically create my user service and my to-do service. So it's creating, starting, and it started. And now we can actually just go to this to this endpoint. It's actually listening on this endpoint. Let's make some requests. Let's say we want to get the to-dos. So we have here the list of to-dos. This is the route. Remember, we're calling to-dos here, and we're getting a list of to-dos, but it's actually behind the scenes. We're calling one service that is calling also the user service, which is returning the user, and then we're calling an external API to get the to-dos. Let's say I'm using with a specific ID here. So the same flow is happening. We're going to to-do service, which is calling the user service, returning the user, and then calling an external API to get the to-do that you requested and returning it to us. Specifically, I'm using a Specto as my tracing backend, but you can use on any other vendor, or you can actually use Jaeger, which is a popular open source project. I'm going to add the link in the description to a tutorial to set up Jaeger with OpenTelemetry. So we're actually going to see here, because we made some requests, we can see the green indication that says, okay, the traces that we generated arrived successfully at a Specto. Let's continue. And we got this nice view that we can actually see requests that we've done. We can see here a filter on the services. HTTP methods, status codes, basically different things that you can play around with. And let's look at the last 5 minutes. Let's generate some more data. So we're calling to-dos again. Let's look at the ID number 5, for example. And then we should see the data in a Specto shortly. So here we can have an example of a trace. So let's look at this trace and see exactly what happens. So we said we're calling a to-do service. So we're calling to-do. You can see here the URL. And then you can see that we called an external service. You can see it right here. We are in the to-do service, but then we call it the user service to get the user ID. And then we called the external API. It shows up here as external API. You can see the URL here, which we got the to-dos from, and we actually returned it to the user. So you can actually get a picture of your entire flow from the browser to a service, to another service, to an external API, and that way you get a clear view of your entire flow. And if we're going to go back here, we're going to see also the call for a specific ID. So you can see here we called for to-do with the ID 2, and you can see the same flow for that. So this way you get a really nice and clear view of your system across different services. So this is really what it takes to get started with OpenTelemetry. You need to install a few packages in your application. You need to run it with the OpenTelemetry instrument command, and that's it. And you have traces. It's dead simple. It's very easy. So go ahead, sign up to a Specto and get your token and get ready and send us some traces. So I'm going to include in the description a few links to learn more about OpenTelemetry, about Python, and to see a bit with the Specto to play around with our playground. It's all going to be down here in the description. So click on and go and learn more about OpenTelemetry. So thank you for watching, and check out all the other awesome videos that we have in this channel. Thank you.